Hello everybody. Today's lesson on this video covers lesson 10-3, and today we're going to talk about operations with radical expressions. And these operations are going to be very easy in some cases, but in other cases they might be a little bit tricky. But the key thing to remember is that we have to use what we learned yesterday in lesson 10-2, where we simplified those radical expressions. We can't forget about that lesson, okay? There are going to be cases where we're going to have to simplify these radical expressions because there's still a perfect square contained inside of them. And I'll go over that here in shortly. So your assignment was 1 through 13 odd on page 637. And I'm going to do some of the even questions to kind of help guide you along with these. Remember, the answers to the odd questions are in the back of the book, so make sure you're checking those out. Make sure you're doing the questions right. And so let's just dive right into it. Let's start with addition and subtraction. Much like adding or subtracting with a variable, when you add or subtract with the radical sign has to be common. Like it has to have the same base in a sense. So they have to have the same term, right? So like if you wanted to add 2a and 3a together, you can because they are both the same variable, right? You can do that. That's still 5a. However, if you wanted to add 2a and 3b together, you can't do that anymore. You have to leave those separate because we don't have that common factor there. So if we're looking at it, right? So for example, on like number 2, we have 8 root 3 plus 5 root 3. And the nice thing about this is we can just add those numbers in front, right? Since we have the common radical sign, we can just add the numbers in front and then keep the radical, right? So we know we're going to keep the radical of 3, and then we can add the 8 plus 5, which gives us 13, right? So we know that the answer has to be 13 root 3. Now, the reason why this works, if you're kind of confused, you're like, oh my gosh, this is blowing my mind. How does this even work? Well, think about it. They both share a common factor of root 3, right? So we can factor out that root 3 because they both share that factor, and we can say, okay, what's left? Well, 8 plus 5. What is 8 plus 5? Well, that's 13, and then we have root 3 left, so that's the same thing as 13 root 3. So that's why that works, right? That's kind of a little proof on why that works that way. So moving on, same thing works with subtraction. So like on number 4, 3, you can do the same thing. You don't need to do anything special. Remember, if there is no number in front, then we assume it's just a 1, right? So on number 3, that would be a 1 in front of that root 7. Now, when we get to questions like 5 and 7 and 9, or let's just focus on 5 and 7 for the moment, we don't have those common radicals anymore. And that's because we don't have a fully simplified expression yet. So what we have to do is we have to go through and simplify it as far as we can to see if we can add or subtract anything together. So to kind of help you out with 5 and 7, let me go ahead and try number 6 here. So we have root 12 minus root 3. Now, root 3 is simplified as far as it can go. We cannot do anything with root 3. However, root 12 has a hidden perfect square in there, right? We can factor it out into 4 and 3, right? Because 4 times 3 is 12. And we can take the square root of 4. The square root of 4 is 2. And then what's left? Well, that's 3. So we're left with 2 root 3 minus the square root of 3. Right? And remember, when we're left with, when there's no number in front, we assume it's a 1. So in this case, I would do 2 minus 1, which is just 1, and then we're left with the root 3. Right? So my answer for like number 6 would be root 3. Okay? With a question like number 8, so number 7 goes along with number 8, we have 3 terms this time. We have the square root of 27 plus 2 root 3 minus the square root of 12. Okay? Now, 2 root 3 is simplified as far as it can go. However, square root of 27 and square root of 12 can go further. We can simplify those more. Square root of 27, if we break that down into 9 times 3, we know that 9 is a perfect square. So the square root of 9 is 3, and we're left with root 3. Plus 2 root 3, because we cannot simplify that any further. And we just said before that square root of 12 can be simplified into 2 root 3. Now we have common radical signs where we can add or subtract all of these together. Okay, so we can add 3 plus 2, well that is 5, minus 2 is still 3, right? These two are just going to cancel, so we're just left with 3 root 3 for number 8. Now, remember with these radical signs, if you don't have common radicals, you simplify it down as far as possible, and you're like, okay, now what? These things won't go together. Just leave them separate. Okay. For example, maybe you get something like 3 root 2 plus 7 root 2, or sorry, 7 root 3. Okay, those two are not common terms, right? The root 2 and the root 3 cannot go together, so we just leave them separate. That would be your final answer. All right, you would not add the 7 or the 3 or the 3 and the 2, right? You have to have those common terms. Moving on to multiplication. With multiplication, it's kind of nice because we don't have to have the like terms. We can just multiply them as they are. So with like number 9 and 11, on 11 you have to distribute, but with like number 9, let me do number 10 as an example. You have on number 10, 4 root 3 times 8 root 3, right? And when you multiply, you have to multiply things that go together, right? So the 4 and the 8 would multiply. We know that is 32. And the square root 3 and the square root 3 would also multiply together into root 9. Now, this one works out very nicely in this case because we know that root 9 is 3, right? That one is a perfect root. So we could do 32 times 3, which is 96. So sometimes these ones will work out very nicely. Number 9 will not be as nice as number 10 was, though. So with number 11, I'm going to do number 12 as an example. You can distribute the root 5 into the root 2 and the 4 root 2 if you wanted, but in this case you wouldn't have to. You could just add those two together and get 5 root 2. Let me just show you how it would work if you didn't want to do that. So for example, you could distribute the 5 into the 2, so that would actually be root 10 plus, and then distribute the square root of 5 into the root 2 plus 4 root 10, and we would get 5 root 10 as a solution. However, we have to make sure that we are completely factored as far as we can. We got to make sure we can't factor anymore. So I have to go back and double check, right? If I break 10 down, 10 only has 2 factors, 5 and 2, right? Neither of those are perfect squares, so square root of 10 cannot be factored any further, so that would be my final answer for number 12. Okay, so always go back, double check, right? If you go to the back of the book and your answer is not quite the same, maybe, just maybe, you haven't fully simplified yet. Maybe at that last step you didn't go and make sure that there weren't hidden perfect squares inside that radical. Okay, so I hope that makes sense. With number 13, all you have to do is plug in the base and the height and multiply everything together. I'm comfortable that you should be able to know how to do that. If you are struggling with it, though, make sure you email me. Tomorrow there will be Zoom hours. You can always join in on that. So yeah, just stay up to date on that stuff, and you guys are doing a great job. So have a great day, and thanks for watching.